So welcome along to topic 3 of computer programming, and this topic is about structured programming, editing programs and testing programs. So first of all, just a little topic, what is structured programming? Part of the exam blueprint for this subject states that we need to know the difference between structured and unstructured programming. So it's actually very simple. So programming that's considered to be unstructured uses this thing called the go-to statement. Okay, and what would happen is the program would run, and then there would be a statement called go-to, and then it would jump to a different part in the code, then it would run again. Okay, and there was a publication in 1966 by this chap Dijkstra, that says "go-to considered harmful." Okay, and that was this was the birth of structured programming. So now this Dijkstra, he is quite important in computing. He created also the shortest path first algorithm, sometimes called Dijkstra's algorithm. So he's an important figure. So here's an example of structured programming, which is what we use. Okay, and we have these if statements, and then we have loops and things like that. And the unstructured approach just involves, we have an if, and then we say go to 2, and then there will be some line 2, and then we could say go to 1, and then we'll jump back to 1. So this is the unstructured approach. So as long as we know that an unstructured approach uses go-to statements, and a structured approach has loops, and you can see that the code works its way around. Okay, so this is a much older form of programming, and that is all you need to know on the difference between structured and unstructured programming. Okay, so the next topic is editing programs. Now this is a very easy one as well. So when we edit a program, we usually use this thing called an IDE. Now an IDE is an integrated development environment. Python has an IDE that comes with it automatically, the default IDE, and that is idle. Now the reason it's called idle, it's a bit of a kind of recursive joke. It's named after Eric Idle, and Eric Idle was one of the actors who starred in Monty Python. He's in The Life of Brian, if you've ever seen that film. And so they named it, because his second name is Idle, they named the IDE after him. Okay, so the Integrated Development and Learning Environment. Now, the thing about idle is it's written in Python. So you can, when you download and install Python, you'll get idle with it. It's very, very good for just getting started, basic Python. But really, we generally want to try and use something with some more features. So there are some other options available to us. Now, hopefully we've seen idle before. It looks a bit like this. We can turn on the dark theme. We can write a program, and we just press F5 to run it. Okay, so if you have a Raspberry Pi, or any operating system, but these typically come with a lightweight operating system. These are two quite common lightweight IDEs. Okay, so they are small in size, but they're more full-featured than idle. And then we have something like Spider, which is like a fully integrated data science development environment in Python. So this one being probably the largest of the editors that I've shown you. And then we have Project Jupyter. So Project Jupyter is a non-profit open source project started in 2014, and it evolved to support interactive data science and scientific computing. Now, it's 100% open source, and it's free for everyone to use. And Jupyter Lab is the next generation web-based user interface for this project, and that is what we're going to be using in this class. So let me just give you a little look at the about on Jupyter before we go on to the next topic. So the good thing about Jupyter is it's developed out in the open, so you can look on GitHub and you can see the current development of the project, and look, here's all the people that are involved, special election committees and steering councils and stuff like that, subcommittees, trademark subcommittees, some retired steering. So we're perfectly aware of who's developing the Jupyter project, who they are, what they're doing, and what's being done, because it's open source. So this gives us some transparency in what we're using. Now, down the bottom here, we should be able to see Jupyter, link to Jupyter Lab. If we click Jupyter Lab, okay, we can see that there's some guidance on setting it up there. Okay, personally, I like to just, when I install it, I just like to use pip to install it. But there are these other ways, like if you were using one of the Apple company's computers, you likely have to use this method. And I've no idea what Mamba is. No idea. Oh, like if you're using Mac OS, watch out for Python 2. Okay, so that's editing programs. So one of the topics of this is that we just have to know how do you edit a program. You need an editor. What editors are available? There are many, and there's some examples of those. Okay, so the next part is about testing. Okay, so a couple of quite simple topics there. Now we're going to talk about testing programs. Now, testing is the second last step in the programming process. Okay, and the basic idea behind testing. So there are lots of jobs in Edinburgh in testing. A friend of mine has a job just now, just got a new job. There are whole testing departments, and there's this thing called the Software Development Lifecycle, the SDLC, and part of that is testing. So what will usually happen if you're working in a company that has software, you'll have some servers or some software that's being used by customers, and that is called in production. Okay, so software or products that are in production, servers that are in production. Okay, now what you won't do, let's say you want to add a new feature to the software, you won't just go to the production server and just start typing, just start changing things, because that would likely break the current environment. So usually there's a separate environment, it's called like dev or test or pre-production, and this environment will allow you to set stuff up and test it. Now, part of the development process is once you've created a new feature or added something to the software, you'll then send it to be tested, and the testing department are sometimes called QA, quality assurance, or maybe just called testing, software testing. So what they'll do is they'll run through the software, test it, and then if they're happy with it, they'll pass it on to the next part of the software development lifecycle, and usually that would be change management. Change management, document and implement changes, and what would then happen is your software change would be scheduled and would likely be done maybe over the weekend or at night. Now, if you were a UK based company, maybe it would be you would have staff in India that would do it during the night, or maybe in Singapore. But if you were an American company, the staff might even be in the UK that are doing it, because we're behind them. So when I've worked in a bank before, we worked in change management, and we would implement changes for an American company before the stock market opened. We were in earlier. We started at 7 in the morning in the UK. The stock market wouldn't be opening, or the banks wouldn't be opening in America until 1 p.m. So we had some time in the morning to implement stuff. So, when things get tested, there are different types of testing. Okay, now a bug is just an error or a flaw, and usually we'll find this while we're writing the program. Okay, we can run debugging while we're writing the program. Okay, so a software bug is just a flaw in the program. But let's say we've done all our debugging and we say, oh yeah, it's working. We can send it off to testing and they can conduct different types of tests on the program. So this first thing that we might put together is a test plan. Now, that sounds really complicated, but actually a test plan is just a list of tests that we're going to do. It can just be a Word document. Okay, so if you imagine, let's say you've written a program that adds two numbers together. Let's write a test plan for that. We could open up a Word document and we could say, okay, test number 1, input two numbers does total, input 2 and 2 is total 4. And if it is, you would say yes. So you could try a few different numbers, and then you could say, okay, what happens if you input 2 and x? Does it still work? Does it give an error? What do we want it to do? Do we want it to return an error? What happens if we put in question mark and question mark? What does it do? Okay. What happens if we put in 500, like the biggest number we can type? We just hold down the letter 9 on the keyboard for 5 minutes and then run it and see what happens. So we could write out a case of specified inputs, execution conditions and expected results. And you can imagine this in a Word document. It would just be like test number 1, inputs, expected output, result. So we could just make a table, and then a tester could just go through and fill all this out. And so if you were writing programs of a similar nature, you might even have some kind of a default test sheet. Okay, so that's a test plan. The first type of testing is called black box testing. Now the reason it's called black box testing is because you can't actually see what's inside the program. So imagine you have a program that does something very complicated. You don't want to know how it works inside. So you can imagine that program being in a box with like a black sheet over the top of it. So you can't see what's happening in there. All you can do is send things in and see what comes out the other side. Okay, you don't know anything about the code in there. Okay, so that's you're testing the software as if it was one complete thing. Now, the other kind of testing, okay, is called white box testing, but sometimes I think a better name for it is glass box testing. Because in glass box testing, you can see what the code's actually doing. So if you knew what particular areas of the code were doing, you could write tests to target those particular areas. Okay, and that's called glass box testing. So when you have knowledge of the code inside, you're not just sending stuff in and then getting it to come out the other side. So those are two kind of classic testing scenarios. There are a few other types of testing. Now I'm not going to go into them all in great detail, but we'll just cover them in a sort of basic way. So the first one is acceptance testing, or user acceptance testing. So the basic idea of this is that you have some tests that the actual requirements or expectations of the customer. So the customer wants a system that does this. Will they accept this? So testing the functionality of the system to see if it meets the customer's requirements. Okay. Now the purpose of this is to evaluate the system's ability to comply with the user's requirements, whether it's acceptable to deliver it to the customer. Automated testing, a very easy one. Let's say I said to you, right, I want every program, every single script in this company to have the name of the person who wrote it, the date, the department, and a title. I want a default header on every single script. I could easily write a program to check out each script, to automate going around and checking them all to see if they have there, and we can just run that. So automated testing, you can have like testing tools and you just run it over the software and it'll check it. Could be checking it for security vulnerabilities, could be checking it for accessibility, but we can automate all of this. Okay, regression testing. Right, this one, let's say you've added a new feature to a website that there's a nice little slider that a customer can like slide their order and see how much they've ordered and their bill will change or something like that. You've added that and you say to the testing department, right, I have added a wonderful new feature. Can you please put it to change management and we'll get it into production? And they're like, yeah, sure. Let's just go and do some regression testing on it first of all. And then they come back to you and they say, oh, you added this feature but you broke 5 other things while you were doing that. So we need to make sure that any new features are backwards compatible with old features. Okay, so regression testing is making sure that new features don't come at the price of breaking old features. Functional testing, you're concerned with what the system does from a functional perspective. Do you get the result that you want? Okay, so quite simple. If I put in an input, do I get this output? Almost like what I was talking about with the test plan. And then I've got a list here of just some other forms of testing that we could do. So load testing, kind of similar to stress testing, I suppose. Recovery testing, performance testing, security testing, usability testing, accessibility testing, exploratory testing. So there's lots and lots of different tests that you could apply to a program. And that is topic 3 of computer programming. Now, what I've added here at the end is this PEP 8 is Python's style guide. So let's just have a look at the guide to PEP 8 here. Let's just have a look at the syntax checker. So put a guide here from realpython.com that explains things that you should do. So for example, if you're writing a variable, you shouldn't write it with capital letters, for example. That's the style that they should be written in Python. Okay, same with functions, which we'll get to later. Now, how to choose names. Choosing names for variables can be challenging. The best way to name things is to be descriptive when you name them. Okay, so like my list, or list of animals, if it's a list of animals. Okay, list of names would be a good one here. Okay, code layout. So blank lines, adding spaces between things is useful. Now, I'm not going to go through this whole. Here's a little bit about comments. So, if the implementation is hard to explain, it's a bad idea. There's a good quote from the Zen of Python. So, if someone ever tells you something and they can't explain it, then maybe it's not such a good idea. So here's an example of a block comment, and then there's an inline comment. Now, they say that you should use inline comments sparingly. Okay, use them sparingly. Don't really use so many of these inline comments. Only use them if you have to. Right, so what I've got here is this is an example of a syntax checker. So if I was to write something like print, well, let me just write in here, print, let's zoom this in a wee bit as well. Right, hello, there, okay, and then I was to write like x equals 5, so I print x, so comment this is x, so my list equals 1 for my list print. Right, so there's just some random Python I've just made up, okay? Put a little comment at the top here. Random Python I made up. Check code. So, the Pepe style checker, okay, has found lots of errors in my code. Okay, so see what it says E256. Block comment should start with the hash symbol and a space, right? What it's asking me to do is put a space there. So now if I go check again, that's gone. Now, missing white space around operator on line 4. Line 4. So it wants me to do that. At least 2 spaces before inline comment. Check. Does it like that? Missing white space around operator on line 8. Alright, okay, I see. Check again. Missing white space after comma in the list. So let's go, maybe here, here, and here. Check again. And finally, no new line at the end of the file. So let's just add a new line there. There. Check. Oh, now we've got a blank line at the end of the file. What? Try that. Check. There we go. Okay, so this is now PEP 8 compliant. Okay, it wasn't at first. I deliberately wrote it so it would be bad. So what you can do is you can just paste your program in here and hit check, and this will help. Now, the Python code will still work if it's not PEP 8 compliant, but making it PEP 8 compliant should make it much more easy to read. Okay, so what I'm going to do is I'm just going to stop this recording now and see if anyone wants to ask any questions about any of those topics. Right, okay, so okay, my first computer was a Macintosh 2, an Apple Mac 2. Anyone else have that as their first computer? No. Anyone want to suggest what? Anyone got any good first computers that they want to say? No one. We'll just start alphabetically then.
I had the Pentium 4.
Pentium 4. That's a classic.
Commodore 64.
Commodore 64. Oh.
Technically a computer.
Yeah, we'll just put C64 there. Commodore 64. Yes, it is a computer, definitely. Did anyone have an Apple computer for their first computer? No.
I never used Apple.
No. Oh, okay. Sometimes there's the iMac G3 was quite a common computer. The coloured ones were quite common. Alright. Pentium 4. Oh, I suppose that can go into this one under here. Did anyone have a Dell as their first computer? No Dells.
Yeah, I do.
A Dell, yeah. Interesting. Very exciting. Alright, okay. So, right, now we'll speak about today's computers. Who has the fastest CPU in the whole class? Who's got the best CPU? Does anyone have a Core i9? No. Okay. I'll tell you what I've got. I've got quite an old computer. I've got Core i7, like 2nd generation, and it's 3.4 gigahertz. Does anyone have a better CPU than this? 3.7. 3.7 AMD is it? And is it a 6 core?
I don't think so.
No, what? Just a 4 core?
Actually, let me check.
If you go to, so see for example for me, I can go to here and I can go settings and I can do about, and it tells you that it's got 8 cores. But also, I think in Windows, if you go into the task manager, like you can open up something along the lines of, if I go settings and go, no, I don't want that, I want like system monitor. If you go to there, right, you should be able to see like all your CPUs and what kind of what they're doing at the moment. Alright, so I can see I've got 8 different CPUs and all the stuff that they're doing at the moment. Okay.
Yeah, about 4 cores.
4 cores. Oh. So you've got more gigahertz, but less cores. So I bought this CPU second hand. It's actually got a big scratch on the top of it, and it was like, I think it was about £60 off eBay, not that long ago, last year or something. I always wanted a Core i7, but they were always so expensive. I wasn't going to spend like £350 on a CPU, so I waited until they were only £60, and now I've got to my dream of having the Core i7 that I always wanted. My dreams are simple. Right, does anyone know any other languages apart from Python? So I'll put down the ones I know. Python, R, C#, JavaScript. I think that should be a capital S there. Does anyone know any other languages? Anyone want to add any to this list?
HTML5.
HTML? Oh, I don't know if that's a programming language. HTML. Not really a programming language, is it? Let's just take that off there. What about, has anyone done anything maybe at school? A different language at school?
Light code?
Light code?
No, light code.
Oh, live code. Is that like JavaScript?
It's, I think so. It's like similar to some. It's either C# or JavaScript.
Right. Interesting. Okay. Well, I'll tell you, the Python is probably the best thing that you can learn just now because it's the most popular language. So if you've not done any other languages, then it's probably a good thing. Right. Let's go on to the questions and see what we've got. So I'll start from the top. So first person going to be alphabetically discriminatory. The first person is Balram. Do you have an answer for question 1? Okay, we'll take that as a no then. Let's go Claudio. You'll have an answer for question 1, I guess.
Well, I don't know if it's correct, but I did like.
Do you want to paste it into the chat? So see to paste, you just highlight and you do Control C. Is the easiest way to paste.
I'll do, but I
'Cause if-
think it's wrong.
It's not wrong, surely. It's not.
I don't know if it's correct. This way it was.
That looks exact. Well, no. Right. So here's what we've got. Right. So print oranges box 1, print oranges box 2, print total oranges. Right. The problem with that is that that's just going to print these things out here. Okay. So if we run that, it's just going to print these out. But that's not going to give us the
I
total.
was thinking to make a string.
Right.
Together.
Yes, that's what you would do. Yes.
That one I want to do.
So let's. What about the next person, Daniel? Have you got an answer for this? You'll be amazed how quickly I could get through a whole list of people.
Sorry, do you mean the first question? Or
Yes, this one, question 1. Yes.
Oh, okay.
Do you want to
so I just
paste it in the chat? Just see if you just highlight it and do Control C. You can just Control V it into the chat. Don't right click because you get this a million different options of all sorts of. Yes, right. So that so that kind of answers it. Copy. So we'll put Daniel's solution here. Now this adds them together, right? But the problem is it doesn't print them out. So what we need to do is we need to take his first solution and merge it with the other solution, and now if we run this, we get a syntax error. Why do we get a syntax error? Total oranges because we need to put an underscore there. There we go. Okay, so that's question 1. So all we've done is we've taken this, we've got this variable and we've assigned it the value of this variable plus this variable, and then we're just going to print it out. Okay, so that's question 1. Right, let's move on to the exciting world of question 2. Who's next in the chat? Andrew, do you have an answer for question 2?
Yeah, give me a sec.
these exciting notebooks, the exciting world of Jupyter notebooks. Oh, here we go. Nice. Right. Print hourly rate times. Oh, that's interesting. Right. Yes. Now that's a good answer. Now, I actually probably wouldn't have done it that way. That's a little bit too fancy for me. What I probably would have done was I probably would have made another variable. So what we can do here is we can do like total pay equals, and then grab that, pop that there, and then print total pay. But exactly, perfect answer, brilliant. Okay, put a space there, like to be Pepe compliant. Right, okay, next person in the chat, let's move down the list because we're running out of time. Hector, tiene una respuesta por pregunta 3.
Almost perfect. Actually, I didn't do the question 3 because I would like a little bit of struggle, so I just jumped to question 4.
Okay, no pasa nada. Right, let's move on to the next person. James, do you have an answer for question 3?
Yeah, 1 second.
Oh, I'm always excited to see what these answers are for people. So, what we're going to do in this class is each week we'll do one of these and they'll get... Oh, wow. Oh, wow. Somebody's been doing Python. F strings and everything. Now that, let's run that. Right. Now that's pretty fancy. It's probably better than what I would have done. Right. So there's a very good answer. Well done. Right. God. Right. So that's pretty good. Well done. You must have done Python before. So here's what I would do for this. Right. So the problem is we've got a total, and we're going to divide the total by 3. Okay, so what I would have done is I would have done let's just see if I can do this. So total water divided by 3 equals let's say, I don't know, I don't know, 1/3. Right? Cannot assign to operator. 1/3 equals total water divided by 3. So it's just that answer was that spectacular that it's thrown me off, alright? See if that'll work. Right, okay. So now we've got a variable called 1/3. See if I print 1/3. We've got 1,000, okay? Well, let's just do that. Now all we need to do is we can do 1/3 equals jar 1 equals jar 2 equals jar 3. I think that'll work, and then we just do print brackets jar 1 jar 2 jar 3. Hang on, I've done this wrong somewhere. Oh, hold on, it should be the other way around. Let's just pop this onto the end. Like that. Okay. So what you can do in Python is you can like daisy chain the assignment, and all of these will be assigned to the one on the end. So you can assign like multiples of these to that. So that's obviously James's solution was a lot more elegant than that, but I'm just thinking of like ways that you can do it in the most basic way possible. Right. Okay. Next one. We have Jamie. Do you have an answer for question 4?
I'm actually just a note taker, Michael, so I don't
Oh,
have
sorry.
an answer, I'm afraid.
Sorry.
Don't worry.
Why don't you have an... Well, what have you got in your notes for question 4? No, right, okay, let's move down. Next week, Jupyter Lab. Okay, so we have Christoph. Do you have an answer for question 4?
I'm just going to run it to see if it's working, and I came across an issue. But I'm going to print it. I'm going to, paste it in the chat.
Yeah, do that. it's better if you put something in the chat that's wrong, and then I can tell you why it's wrong. Well then. Do. Nearly there. Right. Yes, exactly. That's exactly right. Yeah. Easy.
That is actually not, the spelling is wrong.
Yeah, you've spelt that wrong, but that's will let you off. Easy. Alright. As long as you know that the area is the width times the height. Okay. There was one time where my idiot brother and my mum tried to measure a room for a carpet, and they measured it wrong. And so when they came to lay the carpet, they laid it all the way to the end, but it was like a foot short at the end because they didn't measure the room properly. So they didn't obviously know this formula of area equals width times height. Right. Again, this is another fairly straightforward one. How many people have we got left in this? Not very many. Lewis, do you have an answer for Q5?
Yeah.
And then we'll just keep running down. Marcus, do you have an answer for question 6? Nicholas, do you have an answer for question 7? So there we go. We'll tackle these as a group of 3.
I've got one for number 7. I didn't get one for 7 or 3. I've got one for the other ones.
Okay. Nikki, do you have an answer for question 7?
Yeah.
Paste it in the chat. Right, Lewis has put something. Look at this. I like this one. So we're back to high school maths here. Pi r squared is the formula of the what on earth happened there. So let me just copy this. Pi r squared. So area equals pi. Right. So you're doing area equals pi times r times r, like that, and then print area. That would work, I think. Yes, that worked. Another thing you can do, and let me just show you, this is a part of the magic of Python, okay, is you can do like this. Watch this. Take that away, and you can actually do that, and that'll give you squared. Pi times, I think. Well, I'm going to run this and it'll be wrong probably, but yeah, that's wrong. Hold on. You can do pi r, is it this? No. Okay. Let's just stick with your solution now. There's definitely a fancy way of doing it though, I just can't remember it off the top of my head. Yeah, that would work. That's the right answer as well. Okay, resistance times current from Nikki for question 7. Look at that. Doing it in the print statement as well, like Andrew did up there. And the last one, question 6. So, I'll do this one. So, the area of a triangle is 1/2 base times height. Alright, so all we need to do is do base times height. Spell height. Base times height, okay, so print base times height. Yeah.
I put on the chat.
Oh yeah, C equals
You did
base
that
times.
one, right?
Yeah, that's pretty good. I was going to do it like this, times height. Yeah, pretty much. I was trying to do it in a really silly way, but you can do, what you can do is you can do area equals base times height in brackets, right? And then we could multiply it by 0.5. And that would give us absolutely nothing because we didn't print it out. Print area. We could do that, or we could do divide it by 2. Doesn't like take away the times. Okay, we could do that. So the area is 10 of this triangle apparently. And if you think about it, right, visualize it in your head. It's a right angle triangle. Imagine it was a rectangle. The area would be 20. So we draw a line right diagonally through it, we're going to get 10. Welcome to high school maths. Right, okay, so hopefully that's helpful for everybody, just seeing the different solutions and stuff, because in the past people said, oh, I just gave you stuff to do, but I never actually showed you any solutions. So what I'm going to do now is there's a new section about to become available on Moodle. So let me just edit this, make it available. And editing and testing it's called. Okay, so let me just share over this new section on Moodle. So this week what I've done is I've added a link to the Pepe syntax checker. There's also the PowerPoint that I went through. Bear in mind, all of these classes, the videos are on YouTube for the classes on my YouTube channel. Okay, so if you don't know, if you haven't been to my YouTube channel yet, if you go to, I'm not looking for subscribers or anything. I'm just telling you that you can go to my YouTube channel, click playlists, and you can listen to my uplifting trance playlist, wherever it is. Uplifting, no, I'm just joking. Go to Introduction to Computer Programming with Python 3. View. Oh, okay. So I meant to add the other. I should have added the other video into there. Right, hold on a minute. I can do that. I'll do that on the spot, right? Because I had it a second ago. Back. This is the video from week 2. So I should move that to the playlist. Computer Programming with Python 3. Do we want? Yeah, it should be in that playlist. Oh wait, Introduction to Computer Programming with Python 3. Don't get it confused. There. So now if we go back to the main channel, playlists. How do you get playlists? Uplifting trance, show more. Introduction to Computer Programming with Python 3, scripting for security. Somewhere it's here. Ah, here we go. Introduction to Computer Programming with Python 3. There's week 1 and week 2. So let me just fire that in the chat there in case you don't know. So week 3 will appear there later on. Now, if you, not that I'm telling you to, but if you want to make your life easier, if you just subscribe to me on YouTube, then when I upload the next one, you'll get a pop-up. All right. Okay. So there's a notebook to do for homework this week that's available on Moodle, and it's called Notebook 3 because this is class number 3, imaginatively. So if we click on Notebook 3, hit save, and then you just click the button, it'll just open. You can drag it into Jupyter Lab if you like, but we could just open it as a notebook. Right. So there's some notes in here about some different types of algorithms, or different types of algorithms. Okay, so there's 2 that we describe. The first one is called now I'm going to tell you a simple game, and you already know these algorithms, you just don't know the name for them. So if I said to you, I want you to guess a number between 1 and 10, you would probably say 5. Okay, now that's got a particular name, and I'll tell you what the name for that is in a second. But let's say you were going to try a different method. Let's say I said to you, I want you to guess a number between 1 and 10, and you said 1, and I said no, and you said 2, I said no, and you said 3, I said no, and you said 4, and I said yes. That's called exhaustive enumeration, okay? Because you're starting off at 1 and you just add 1 until you get to the right answer. Now that's fine if we've only got 10 things to check, but if you have like 5 million numbers and I say guess a number between 1 and 5 million, and you say 1, no, 2, no, 3, no, we could be there for a long time. So it's a less efficient way of doing things, exhaustive enumeration, right? So the other method is called bisection search. Now bisection search is sometimes also called interval halving, okay? I'm not sure if that's spelt right. I think it might be halve with an E. Interval halving, right? So if I said to you, guess a number between 1 and 1 million, and you said 500,000, and I said that's too low, and then you said 750,000, and I said that's too high, and you say okay, 600,000, that's too low, 649,000, that's too low, I'd be like okay, 701, right? So what you're doing there, although I'm not doing it exactly, is you're having the guess space each time, okay? That's called bisection search, all right? So there's a couple of examples of how we do this. in here, and then there's just some questions to answer. Okay, so what we're going to do is we're going to write out in pseudocode an algorithm that shows how to count up to 20 by adding 2 iteratively until you reach 20. So when you go over a series of things, okay, that's called iteration, right? Iteration. We have an example of that up here in the notes. Iteration. Working through a problem one step at a time. And an example of that would be exhaustive enumeration, where you guess each number one step at a time. So then what I'd like you to do is create a flowchart of this algorithm. Okay, that you're gonna write out an algorithm in pseudocode here and then create a flowchart of it here. Then there's just a couple of simple questions about printing stuff out to answer. Enter a number, print out a number. So 7 questions there, 1 flowchart to make. Now when you're finished with this, if you export the notebook, right, the flowchart won't work. Okay, the flowchart will disappear. So watch, right? Imagine you have a flowchart, right? I'll just get a flowchart. Imagine this is your flowchart here. Let me just download it. Save image as, downloads, save. Right. So let's say I want to add that into this notebook. Okay, I think I can do that. Double click in this cell and go like this. And then just get your Windows Explorer, your file manager open, downloads, get your flowchart and just drag it in. Just drop it there. And then if you do control return, there it is. Now, unfortunately, you would have to then give me this file as well if you export it. So a much easier way to export it is just to do this. File, print preview, right, see that? It's there now. And then you can just do this, file, more tools, just do Control P, save as PDF, and there you go, look, there's your flowchart saved there. Alright, so I'll show you that again what I did. Okay, I went File, Print Preview, Control P, Save as PDF. You just hit Save. And then it'll save your flowchart in the notebook. And your answers down here as well. And just upload that. Right, so that's week 3, task 3. Hopefully that's not too difficult for folk. Stop sharing now. Would anyone like to ask any questions about this wonderful task of making another flowchart and answering some questions about adding numbers together? Or are we all excited?
Yeah, I have a question. The first exercise you were talking about is like 2 times table as what we need to do, the program.
Pretty much, yeah. Yeah, but you need to write out an algorithm for, like, imagine I'm a computer, I'm a robot, and I don't know anything, and I want you to tell me how to add up to 20, adding 2 at a time. I am a robot. Okay. I'm a simple robot.
When it's gonna print, I need to show all the numbers as I write until 20, or?
No, well, if you write the algorithm in such a way that I can understand it until I get to 20, then it'll be, you won't need to write them all out.
Right.
You could write it in that way, add 2 is 4, add 2 is 6, but you don't, maybe you can, if you could tell the robot a way of knowing about how to do it without doing that, that would be better. I'll let you have a think about it. And the robot's